No problem. Thank you, Kat. Hi, everybody. Okay, let's start. Welcome to another Gazebo Ignition community meeting. Nice to see so many people here. Today we have a special day prepared for you guys. Usually we have just one kind of theme and presentation, and today we prepared a bunch of different demos for everybody with the latest release that we are working on called Ignition Edifice. That's going to be released next week. So let's jump right into it because there is quite a lot to show. So let's start with some quick announcements. I wanted to go over the release timeline just so everybody's aware of what's coming up. So first of all, should let everyone know that we have the t-shirt campaign open already. If you want an Ignition Edifice t-shirt, you can just order on this link here. It should ship worldwide, I believe. This will be open until April 21st. And if you want to use the logo for something, it's also available here, the graphics. So this is it for the shirt. We are already in feature freeze since last week for Ignition. So we're not pushing new features to it. And code freeze is today. So by today, the end of the day, we're going to merge all of the open beta pull requests. And from tomorrow, we're going to only be publishing critical bug fixes that we identified during the tutorial party. Talking about tutorial party, the party starts today as well. After this meeting, the tutorial party is open. Kat posted a nice explanation here on Gazebo community for people to know what to do and how to contribute. And a different thing that we're doing this time is that we are going to be handing out t-shirts for the people who contribute the most. So if you the people who review the most tutorials and contribute fixes for the tutorials, the top 5 people, we're going to be shipping you Edifice t-shirts at the end of the tutorial party. So there are instructions here on how to do it. There is a tracking spreadsheet. If we have time at the end of this meeting, I'm going to quickly go over the tracking spreadsheet with everybody so you know how you can sign up to review a tutorial, how you can make contributions. We may not have time during this meeting, but the entire team will be available. You can contact us through Gazebo community on that post about the tutorial party, or we're also on GitHub. So be sure to talk to us. We'll see if we're going to have time for this at the end of this meeting. And of course, the final release, after we go over the tutorials as a community, everybody checks if everything is working well, push some final tweaks, some final features. The final stable release for Edifice is planned for the March 31st, which is next week, 1 week from now. So everything that we're going to show you today is still pretty much in beta state, still needs some tweaks that we're working on. So it's everything very fresh. Everything that you're going to see during the tutorial party is still in a beta pre-release state. So just something for you to keep in mind, that things are not stable yet and they may change quickly. And we appreciate everybody joining us in this unstable situation to help us make the stable release more robust when it comes out. The other thing that I wanted to mention here before we move on is that we picked a name for the next Ignition collection. Thank you for everybody who filled the poll that we posted on Gazebo community here. We got 55 votes, I believe. And we have a name, and if people are not aware, our theme is architecture. So that's why we have Blueprint, Citadel. Well, the first one was Acropolis, Blueprint, Citadel, Dome, Edifice, and the next one is, everybody's ready for the next name? It's Fortress, Ignition Fortress. So thank you to everybody who has voted. We are going to be making documentation updates and so on soon, but you're all the first to know. And without further ado, let's get into the cool demos that we're going to be doing today. So I'll start Ignition here. This is a demo world that we prepared just to show off all of the nice new features on Edifice. And Rafi, you're up to start talking as soon as the world loads.
Great. Can you hear me? All right. So basically, the process I went with making this world was we focused on modular pieces. So all the walls would be, it's essentially using one or two of the same assets and repeating it. And then how we kind of break that up is with smaller pieces like those pillars and whatnot. And basically that creates a very efficient workflow to create larger environments. And here's a link to something that kind of is how I went about making a demo world like this. And basically, the pros of making a modular environment is if I want to edit any particular texture, it would do a universal change on all the assets that are using the same sort of model. And that's how we kind of made the base layout, and then I tackled individual assets like boxes and whatnot to fill in the demo world itself. As for how I went about texturing, this is kind of a nice little GIF of how texture processes go. I used a program called Substance Painter, and basically all the meshes, they have a few texture maps, a color map. If something's metallic, it'll use a metalness map. If something's rougher, it'll use a roughness map. And basically something new for this demo is we used emissive maps or light maps, and you can see them on the lights right there and on the roof. So those were some unique features for this particular demo. Yep. And for the robot arm, I think we took that out of a fuel model, and basically I unwrapped it and added custom textures and then imported it back in, so it works fine. So that was the other change. And that's how we kind of created this demo world.
Cool, thank you, Rafi. Ashton, you're up.
All right, so thank you, Luis. Gonna talk a little bit about some updates that we made to thermal camera. So Luis is showing here a display of the thermal camera output. If we look down by the smoke that's emitting in the corner, we have Rescue Randy and a box right next to it. And Luis is going to zoom in a bit for us. The main change that was made for Edifice and Dome as well, actually, was we allowed for heat textures to be applied. And I have a video. So let me pull that up. Let's see. All right. Can everybody see what I'm presenting?
Yep.
All right, great. So I zoomed in the two thermal cameras here to see what's going on. So we have we now have two different resolutions. We have a 16-bit resolution and an 8-bit resolution. So it's a little hard to tell what's the difference between the two from this angle. But when this video loops back around in a second, you'll see as I rotate Rescue Randy, the sitting model, around, you could definitely see a difference of the resolution between the two. And to the right of this, we have a box with a uniform temperature. So we now support, uniform temperature objects, or also applying heat signatures to other objects with textures. And then the only other thing is I start emitting some smoke here to show that the thermal camera can still see objects with heat signatures, temperatures applied to them through particles as well. So that's, I think, everything that I wanted to discuss about thermal cameras here.
Awesome, cool. Thank you, Ashton. And I believe now it's Carlos. I'm going to share right now.
Okay, hi everybody. Okay, so I'm going to talk about a feature that has been recently integrated into Ignition Gazebo. It's the particle support, or support for particles. And well, first of all, I'd like to mention, like, what is this what is this thing about particles? Because what we are seeing here is just the smoke, right? But, so I wanted to mention that a particle is like a 2D billboard that we can customize, that we can say, we can specify different properties of this particle. And then when we combine all of these particles together, we create, or we will get like these visual effects that can be like smoke or fire or like sparkles, so those kind of visual effects. So this is something that wasn't available in Gazebo Classic, and it started in Ignition as a new feature. So I'll describe a little bit the process of this particle system. So it's all based on one object that we call particle emitter. So you can actually like instantiate in Ignition Gazebo one particle emitter. And this is essentially, like, the name is pretty self-descriptive, but it's like the object who dictates like how the particles are gonna be emitted. So you can set or assign like different properties to the particle emitter, and like a few examples of these properties are like what's gonna be the type of the emitter. You could say, okay, the type is gonna be a point. So imagine that you are like, I don't know, you have like a cigarette. You want some smoke coming from the tip. So all of the particles are gonna be like emitted from one single point, right? The tip of that cigarette. So you would choose that one. But imagine that you want to produce like a smoke from like a, I don't know, like a big bonfire on a beach. So then maybe you want like a particle emitter who's going to start sending particles from a bigger area. So maybe the type could be like a box or a cylinder or something like that. So you could specify, of course, the pose. I want the emitter in this particular 3D coordinates of the world. You can specify things like the rate, how many particles per second is going to generate, like the duration. So, for example, this emitter is going to be active for 10 seconds or forever. You can say the particle, you can specify the particle size, the velocity in which the particles propagate, the direction. You can assign some materials, some colors, the scale rate. So it could become bigger and bigger and bigger when they move. And that's it. And then when you come up with that set of parameters, you will see like a smoke, or you will see fire, or you will see like fireworks. And it'll be that will generate that visual effect that you want. So and then in terms of API, and that's probably like the last thing I mention about this, is like how do we actually use it? How do we create this particle system? So there are two ways of interacting with a particle system. The first one is via SDF. So I'm gonna paste here an example from the chat really quick. And you don't have to go through these right now. But the idea is that you will have a model, and then inside this model, you will instantiate like the particle system. And then within that particle system, you will specify all these parameters that I mentioned, or the ones that you want to specify via SDF. So there's like for example, like a pose SDF, and then you will say, here's the pose. And that's it. And then automatically, like this will be read by Gazebo, and then it will instantiate the particle emitter based on all the parameters there. And then there's a second way of for interacting with particle systems, which is via messages. So imagine that you have something already running like this emitter, but you want to modify some of the properties of the emitter at runtime. So then what you could do is you could send a message to a particular topic, and then that message is essentially like a particle emitter type. And then you have the ability to modify at runtime any of the properties of the emitter. So, for example, imagine that you want to directly turn it off or turn it on based on some event. So you could do that. You could just change that particular field of the message to true or false, send it, and then that will change the behavior of this emitter at runtime. I'll paste another example here on the chat for how to do that, like via messages. And then that's all. That's all I wanted to mention. Maybe like last thing is like to do. the main functionality is ready. This is all also based on Ignition rendering support for this. And one of the features that it's missing will probably like integrate in the future is like the ability to introspect like the properties of a particular emitter via the component inspector. So this is not ready yet, but something relatively easy to do that we'll do in the future. That was all.
Cool. Thank you, Carlos. Now it's Jen.
Hi, everyone. So you can visualize model collisions defined in SDF files, which can be toggled from the 3D scene or in the entity tree and will be shown in orange. If you take a closer look at the pandas entity tree, you can also turn on and off individual links for collisions. And this will toggle all of the collisions in the link. And then if you toggle the Panda model itself, it will turn off all collisions for all inside all of the model. And another feature is you can use the screenshot plugin to take a screenshot of the 3D scene. And the default is saved to your home directory .ignition GUI pictures, which is shown here, and it will have the file name of the timestamp of when the picture was taken. You can also change that default directory by going into the plugin menu and selecting the screenshot and changing the directory, and then all your screenshots should be saved in that directory. And that's about it.
Let me change the directory here to show how it works. So go to temp, choose, and then I take a picture, and then it's there on temp.
Yeah, we didn't see your file directory come up again.
Again, okay. Well, trust me, I chose the temp directory.
Yeah.
Cool, thank you, Jen. And Steve, you're up.
Thank you. Today I'm going to talk about Mecanum Wheels. Mecanum wheels are a type of omnidirectional wheel. They're often used on skid steer mobile robots, and this allows them to drive sideways. Yeah, there we go. Physically, they have multiple rollers along the wheel. If you zoom in, you can see them. The axes of these rollers point at a 45-degree angle from the axial direction. And it'd be difficult to model all of these rollers, but we managed to come up with some clever parameters for the friction pyramid model in DartSim, using a new feature in DartSim that lets you choose the frame in which friction directions are specified. I just pasted a small diff that shows how some of the parameters have changed. Basically, we say that the friction directions are specified in the chassis frame instead of the wheel frame, because if you try to specify them in the wheel frame, then they rotate with the wheel and end up pointing the wrong way. But if you don't care, then it's basically an easy way to simulate them without modeling all of the complicated pieces within those wheels. And we have a new system for commanding the wheel speeds to make it move in any direction. Similar to you send a command velocity and you can add a lateral velocity component now. I think that's all.
Awesome, thank you, Steve. And Alejandro, you're up.
Yep. Hello, everyone. So we add, as part of the closing the gap between Gazebo Classic and Ignition Robotics, we added the capability to add new lights, in particular directional, point lights, and spotlights. So Luis is adding new lights, as you can see the visual in the scene. Okay. And then we add another capability, which Carlos mentioned about the point cloud, so about the particle effect that is not like enabled yet, but for lights is enabled. So you can check all the properties for all the lights. You can change the intensity. You can change the color, the direction, and many other things. Yeah, I think you need to change the diffuse, change the color, and probably put like a super intensity because we have the light mats in the roof of the wall. Yeah, you can see here the circle changing the light, the color of the light. Yeah, and you can change this in runtime. And if you want to do this also programmatically, there is a new topic in the ignition topics, so you can also send a message to ignition and change the color and all the properties for a specific light, just choosing the name. Yep.
Cool. Thank you, Alex. Ian, you're up.
All right. Another couple of features that we added in Edifice. One is the skybox. So if you zoom out and look out the window, you actually see sky in the background as opposed to just a flat color or a flat gradient color. So this is just a static skybox texture. We use, you can go online, you can find like HDRI maps and convert to cube maps, and it's all static. So if you use Gazebo, before you notice that we have this SkyX feature, which has like nice features like setting time of day, setting the cloud velocity, humidity. That's not supported yet. So if we do support it, we may actually integrate it into Ogre 2 and not Ogre 1. So Gazebo 1 was using, Gazebo Classic was using Ogre 1.x, and when here in Ignition, we support 2 render engines, Ogre 1 and 2. And here, what you're seeing in the demo is actually using Ogre 2. And that's what we've been using for most of our work nowadays. So this is just a static skybox feature. And the next one is Lightmaps, which Rafi has mentioned before. So if you look at the ground there, you actually see light shining through the windows on, projecting on the ground. So those are not actual lights from the sun, directional lights. Those are actually a separate light map that Ko and Rafi have created. So these are pre-baked lighting that you see there. So what we do is we take that light map and we blend it with the base color map, or what we call the base albedo map, to create this effect. So if you put objects over it, it actually doesn't actually block the lights. So they are all static lighting. So the nice thing about using this is that if you have a lot of lights in a scene and you don't want things to be so computationally expensive, you can pre-bake the lights and import that texture into simulation. And then how you would specify it is just to add another line in the SDF, in addition to all the other physically based rendering maps like measurements, roughness, albedo maps. So we support another line called light map. And you can actually set the UV texture set as well, because light map usually use a different texture coordinate sets from the other maps. And I'll just show briefly another quick example. All right, this is another demo world that we include in the release in Ignition Edifice. This is just purely one giant mesh of an indoor environment. There are no moving objects, there are no lights in the scenes, and then we create this using all the physically based rendering PBR maps. So compared to the warehouse or the depot scene that you've seen before, which is a lot more complex, this is simpler. And you can see also the emissive maps on the ceiling there. And then we have reflection maps on the floor. I need to move it slowly so we can actually show. We have nice reflections, and everything in the scene is lit by light maps. So if I zoom in to the corners, On the edges, you can see these nice indirect illumination, which are pre-baked using another rendering modeling tool like Blender or Unity that supports baking the light maps. And the nice thing about it is not just being able to light up the scene, so you can actually also see that there are also shadows below objects. So there's actually, these are darker areas in the scene that are all pre-baked into the light map. And I believe Cole will show how that process is being done next. That's all from me.
Thank you. Let me present the screen here. All right, I'm going to talk a little bit about the process of generating the light maps and environment maps we use for this demo. We used Unity to generate these maps since it was the most straightforward solution. Unity's light mapping system is pretty robust, and its automatic unwrapping tool for light map UVs was also really helpful. Although we used Unity, baking lighting can really be done in just about any 3D modeling software such as Maya, 3ds Max, Blender, that sort of thing. The main thing we need for a light mapped environment is a set of UV coordinates specifically for light mapping. This secondary UV set is different from the UVs used to map things like color maps or normal maps because each polygon surface is receiving different lighting. So each UV coordinate needs to be unique. When baking, we have the option to either bake in all the lighting, indirect and direct, or just the indirect lighting, also known as global illumination or bounce lighting, and use real-time lights for direct lighting and shadows. With the latter method, we get sharper lighting and shadow detail, as well as more accurate lighting on the dynamic objects. However, performance will be impacted by having more real-time lights. Even with all the lighting baked, it's still a good idea to have at least one real-time light. Something like a large point light or directional light works particularly well. And that'll enhance the effects of the physically based materials, like the normal maps and the metal nose maps and that sort of thing. Once we generate the light map, we simply just grab that texture out of Unity and convert it to an 8-bit image in Photoshop, because it'll be a 32-bit image to start out with. In our case, the light map has a resolution of 4096 by 4096, which is actually, so that's a 4K texture. That kind of shows you how efficient these textures are, because that's about the same texture space as just one of the materials that we use in this factory demo. The environment map is used for reflections, and for that we also use Unity by generating what Unity refers to as a reflection probe. A reflection probe, a cube map, environment map, they all pretty much are essentially the same thing. It's a 360-degree image composed of a set of 6 images, one for each side of a cube, or in some cases it's just a panoramic image. We then just open up an existing .dds file, which is the file format we use for our environment maps, and just replace those images in the layers of the DDS file with our generated images and put them in their correct orientation. And then the environment map is ready to be loaded into Ignition. And that's it for me. So I think it's back to Louise.
Yeah, thank you, Cole. That's cool. Let me share my screen here. Okay, so I opened a different world this time. This is a height map world that is coming up on Edifice. The reason I didn't put it together into the other demo is because this one is using Ogre 1, the Ogre 1 rendering engine instead of Ogre 2. So so far we only have support for Ogre 1 height maps. We don't have support for Ogre 2 yet, but that's maybe coming up in a later release. of Edifice. So basically what a height map is a grayscale image where that specifies the height of an area. So you can see that here there's kind of like a lower area in the center and the rest is kind of up. So when I play the simulation, like this is sped up so the things like kind of slide down, roll downhill. So this is using the Dart physics engine and the Ogre 1 rendering engine. And the main difference from the implementation on Gazebo Classic, if people have used height maps on Gazebo Classic, is that Gazebo Classic only takes one height map. And if you try to add other height maps, it's not going to work. But because on Ignition, because we wanted to be more flexible, we made it so that you can open several height maps. So a height map is a geometry like any other. If you go see here, oops, my screen stopped sharing. If you see the properties of the height map, it's just going to show, let me open it again to share. Okay. So if you see the height map link here, we just have a visual and a collision. It's not working when I click on that, so I'm not going to click on that anymore. So basically, it's just a geometry, and you can add multiple geometries to multiple models, each one with their own height map. As you can see, this is not merged yet into Edifice. That's why there's still some little bugs to iron out, but this should be available either in the release next week or in a minor release that comes out afterwards. And it's going to be cool to use this with levels, the leveling system, so that the height maps are loaded up and down as the robot is moving through the world. That's all I had for height map. So now it's Alejandro with Ignition ROS 2 control.
Yeah. Let me share my screen. Yeah, so I'm gonna show you three different demos. The first one is about EGL. Right now, when you try to run Ignition or Gazebo Classic in a server, you need to deal with the display. So you can see if you launch a normal, this is a Docker container, which it doesn't have any display. If you try to run Ignition here, is gonna fail because we cannot find any displays and we don't have support for this. In the new version of Ogre is 2.25. They added support for EGL, which allow us to run Ignition in the server mode, in headless mode. We don't need to care about any displays running. So we can run a world here, which is a camera just displaying some things, and if we just run a subscriber to an image topic, we can generate some images. If I copy this image to my computer, here you can see the camera, which is in this Ignition world without any display, and it's able to generate images and any other things. One thing you need to take in account about this is that you can do this only with software, like let's say with CPU, or you can select the GPU to run all of this. So this feature is not yet merged in Edifice, but I hope that should be merged and available really soon. Okay, the following demo is about the new basic shape that we can add to Gazebo, which is capsules and ellipsoids. So I have here a world with a cylinder, a box, a sphere, a capsule. Sorry, the yellow one is the capsule and an ellipsoid. And as you can see here, is completely like integrated in Gazebo with the physics and other things. Okay, if I remove, for example, this one, I can add, for example, a capsule here, and yeah, we can rotate it. Sorry, select the capsule, yeah. And as you can see, it's completely integrated and working here. Okay, and the following demo is about Ignition ROS 2 control. Recently, we added Gazebo ROS 2 control package to, I think, for Foxy, and we have done the same for Ignition. So right now, you can work with ROS 2 control in ignition. So I will run a very basic demo here, which is just a car pole. You can see here is a car that can move in this pole, and if we run a simple example, it's going to move the car from the position -1 to 1 and return to 0. You can see it's going to do it, and you have here the ROS topics, which is the jump trajectory. We can do in velocity the control. Yeah, here. Yeah. Right now the topics have changed, and wait, sorry. Yeah, the controller is not available yet. Yeah, let's see. Yeah, well, I mean, sorry, here it's available here, and we run the velocity example, and the car is also moving, and we have another sample for the effort. Yeah, so we can control also the car with effort, and if we the controller is not working. Yeah, again, this feature is ready for review, so you have time. Please go ahead and review it. You can see here is the topic to control in effort. If we run this to the effort, yeah, I don't know how to run this with effort mode, so it's a little bit crazy. And the last demo that I'm going to show is ignition gazebo, road to control, and also move it working at the same time. So I have a demo with a dummy robotic arm here, also showing things in RVs, and this arm is gonna move from 90 degrees to 0 and all the time. So you can see here how Move It is generating the trajectories in RVs, and yeah, so we are moving this with road to control. And again, this is something that you can review and give us feedback about. I think that's all. Yes.
Cool. Thank you, Alex. Now you're up, Alicia.
Let me share my screen. Oops. Okay, so I will be talking about model composition, which is something we talked about in the last Ignition community meeting. So if you've seen that, this is very, very similar to that. But basically, what model composition allows you to do is to encapsulate your models and modularize your models so that you can have interchangeable items. So for example, and you have a robot arm, and you have multiple variants of a gripper. So you have this gripper that would normally come with it, I guess, and then this is a different type of gripper. You can have grippers with different actuation methods. And I want to be able to mount this gripper into the end effector of this robot without having to know the numbers associated with the pose. So I don't have to know exactly what how many meters it is from the ground or anything like that. I would just be able to say, specify a point, a frame in this robot and a frame on this gripper, and say, put the two at the same spot. So I will show you how we get to do that. We create a model that includes all these other models, and that's what the composition is about. And this is a new feature added into Edifice. And so I would include the panda arm, and I would include the hand, and inside the arm, I have a frame called gripper mount, and inside the gripper, I have a frame called mount point. And what that allows me to do is to take the frame inside the hand called mount point and put it where the gripper mount is on the arm. And then the joint here is to make sure that they're fixed together. So if one moves, the other moves as well, and they're constrained together. And for the gripper 2, it's pretty much the same thing.
It's just that I have changed the URI to use a different gripper. As long as this other gripper has the same frames defined, I don't have to know the details, the actual poses themselves. I just need to know that mount point is there, and I can just use the same pose specification here. And so if you go back to this, I zoom out, you have these two robots, and they're just, as we expect, they're both fixed in the right places. And then another example is we could take the same idea and apply it to attach this whole entire gripper and arm combination and put it on a vehicle, a UGV. So just like that, I can include the UGV from Fuel, add the controller for it, and then include these other models that I showed you just before, and then have a joint that connects the UGV to the arm. And notice that I am actually using model names here, which is different from before. I couldn't use, these had to be links before. Now they can be any frames. So we run that, you can see that it's right there. Let me run this. So as you can see, they're moving together, and this comes up as one model, and if you expand that, you could see, I don't know if it's too small, but you could see the UGV and the arm separately, and I can actually, this should work, yeah. So I can actually move around the arm as well. Some of the features needed to do things like use the transform tool aren't merged yet, so we're in the process of getting that in. But otherwise, nested models. That's all I have.
Awesome. Thank you, Adisu, and thank you everyone who demoed something. That was a lot to take in. Let's see, we're done with the demos. We have 15 minutes left in the meeting. So I wanted to make sure to give people like a couple minutes to ask some questions about the demos, if you have any right now. If there aren't any, oh, yeah.
Yeah. Hi, everybody. Just a question for Steve. You presented the Mecanum Wheels. Do we have Omni Wheel, something like that already? I don't know.
Like the Omni wheel that has rollers that aren't at a 45, they're at like at the ones that are just like laterally 90 degrees.
Yeah.
I haven't tried to model those. I think, yeah, I'm not exactly sure how I would do that. I mean, I suppose you could just put friction at 0 in the lateral direction, or at a lower level. That might work. So
Okay.
that would be interesting to compare.
Yeah, nice. Thank you.
Hello. I have a short question. Can we change the robotics arm and effector in real time?
That's probably for you, Adisu.
Composition. I believe you can, but basically you'd have to remove one of the, you'd have to do it differently. You'd have to use something called the detachable joint system. And that allows you to attach and detach, like create fixed joints between two objects at runtime. And so you'd have to create that, you'd have to spawn the gripper and then create a fixed joint between them. And then when you want to swap it out, you have to break that detachable joint, remove the gripper, and then add the new one.
Thank you.
So I'll leave more time for questions in the end if we have time. I'd like to move on with the agenda just to show some news that Kat curated for us this week, or this month, actually. So let's see, community meeting, it's this screen. So there is a long list of items here for people to check out what has been happening in the community for the past month. I encourage everybody to go check it out. It's under the community meeting post. I'd like to highlight a couple of them, like the Summer of Code. We are participating in Summer of Code, and applications are open. So if you want to work with us, work on Ignition, help out and collaborate, be sure to check it out and to apply. We have a lot of projects listed here, so if you want to check it out. And the other thing that I wanted to highlight was, I think this is the main one. There's a lot of nice projects out there. There are some projects that you wish you hadn't seen, like the cursed gazebo model. So I'll let each person click on it on their own. This is a very cool project that Kat also found using Gazebo Classic, and has this huge model of Cappadocia. So this is it for the news. Be sure to check out all of these links. And now that we have some time, I'd like to go quickly over the tutorial party and how that's going to work. That's going to start now. If people want to start reviewing tutorials, you're ready to go. As I mentioned before, the 5 people who contribute the most with tutorial reviews will get t-shirts shipped to you. And also, if you're a prospect, like Google Summer of Code student, it's interesting for you to get familiar with Ignition. So if you want to try out the tutorials to get more familiar with the process and everything, that's a great opportunity. So the way that it works, we pretty much organize through this a spreadsheet here, and everybody in the world should have right access to it. So you can just come here and say, oh, okay, I want a tutorial. So you pick a tutorial. There are many categories. There are the more general tutorials here on the top. There are tutorials that are specific to the Gazebo simulator. There is a bunch of worlds that we install with Gazebo, and that you can try it out to see if they are still working with Edifice. So see, there's 72 worlds, I believe. It's a lot of them. There are tutorials also specific to each one of the libraries. So there are tutorials for Ignition Common, Ignition Fuel Tools, and so on. All of them here on the column B have their version live. So if you click on a tutorial, for example, this one, you can see it rendered live, and you can see that it's the tutorial for the pre-release that is not officially out yet. You can go over the tutorial, and if everything is okay, you put your name here under reviewer, like me, and then in the status you say, okay, this tutorial is okay. If it's not okay, if you find a problem, this is the source code for the tutorial, and if you know how to fix it, just go ahead and make a pull request, make a change to the tutorial, and open a pull request. If you don't know how to fix it, feel free to go to the library where the tutorial is and create an issue, and then we are going to take a look into it. Let me remove this. So this is pretty much the step. The platforms that we support are, we have instructions down here to install on Ubuntu Bionic or Focal from binaries and from source. We also have instructions for Mac OS from binaries or source, and Windows, which is something new. We haven't done tutorial parties with Windows yet. So we also have from binaries and source. The caveat is that you can see that there are some cells that are blackened out here, and these are the ones that we don't expect those to work, those tutorials, so don't bother. So for example, if you're on Mac OS Catalina building from source, we don't expect the GUI tutorials to work for you. That's why these are blacked out, so please don't try them out. The same thing goes for Windows, but everything that is clear are things that should be tested, and we would appreciate everybody's help if you can. Try it out. I think I covered the main points. The rest, yeah, just be sure to sign up with your name so we know who you are, and we can send you the t-shirt and contact you for the t-shirt at the end. Any questions about the tutorial party? This is going to be open until Monday. Yeah, someone unmuted.
Oh, Luis, I was just gonna say, so I was having some issues earlier today with the nightlies on Ubuntu Bionic. I'm assuming that in the next few days, once we get more done with the release, this will probably no longer be an issue, but I just wanted to mention that in case anybody else had that same issue. I think the solution for Bionic, at least like at this moment, is to probably do source, but I had no issues with the Debians on Ubuntu Focal, so.
Yeah, good to point it out, Ashton. So like if you're trying our installation instructions and something isn't working properly, we would love to hear it. So if you can ticket an issue about this or even comment on community, so we know that that's not working and we can sort it out. As I mentioned, everything is under active development. So this is evolving quickly and we're fixing things all the time. So really, like if you run into something that is not working, speak up, because it may not be you, it's probably us. That's all I had. I don't see any other items in the agenda. Do people have any final questions about the tutorial party or about everything that we presented here today? How you can try out Edifice, anything like that? I guess it was all very, very clear then. Okay, well, thank you everybody for joining. We hope that you guys enjoyed the release. We hope that people help us out reviewing the code and making sure that we ship a robust release when it comes out. And yeah, if there's no questions, we can wrap it up here. Okay, and thank you again for everybody who demoed their stuff. That was very cool. Okay, see you. Bye-bye.
Thank you. Goodbye. Thank you, everybody.